Alrighty, welcome to the first of two videos that I'm going to do on naming things in chemistry. And today we're going to talk about naming ionic compounds. When we talk about naming ionic compounds, we're really referring just to binary ionic compounds. And what are binary ionic compounds? Or binary ionic compounds are just compounds made up of one cation, and one anion. And we know from previous videos that the cation is positive. It's got that T in it, which looks like a positive sign, which refers to the positive charge on that cation, and the anion, which is negative. And in this case, almost always the cation is going to be a metal. It's going to be a metal, and the anion can either be a nonmetal or it can be polyatomic. And these are slightly annoying, but slightly interesting as well. They're ions composed of more than one atom, but they're treated as one group when they form compounds, and we'll look at those in type 3 in a little bit. But first, we'll just look at some very standard binary ionic compounds and look at how we name them. And to do this, we're just going to look at a bunch of examples. And so I've got three compounds here that I'm just going to name for you, and then we can talk about why I'm naming them this way. So the first is NaCl. We know this as a common table salt, or sodium chloride. Sodium chloride. I know this is sodium chloride because, of course, Na stands for sodium and Cl stands for chlorine. What you'll notice I've done here, though, is sodium remains unchanged. So the cation, in this case, remains unchanged. But chlorine, you'll see it no longer is chlorine. It's become chloride. So I've replaced chlorine with chloride. And similarly, you'll see here, this is calcium bromide. Calcium bromide. So I've taken the cation and left it as it is in its elemental form, in its elemental name. But for the anion, I've changed the ending. I've appended the ending of the anion from INE to IDE. And that's what we generally do when we name binary ionic compounds. We change the ending of the anion to include an "ide." And so maybe you can guess what's coming next. This compound is potassium sulfide. Potassium sulfide. Pretty simple stuff. But we're going to up the ante a little bit when we talk about this second type of binary ionic compounds, and these involve transition metals. You need to do a little bit of thinking when you look at these. So whenever you see a transition metal in the cation of your ionic compound, you should take a step back. You should take a deep breath and then enter the problem, knowing you're going to have to look at a few things before you name the compound. The first thing you should do is look at the charge on your anion. You know chlorine is a halogen, so it's going to have a charge of -1. This means that the copper can have a charge, must have a charge rather, of +1. Well, that's good. So you might think we just write copper chloride and you're done with it. But the problem is copper doesn't always only lose one electron. Sometimes it loses 2 and takes on a state of +2, takes on a charge of +2. Sometimes it loses 3 electrons and takes on a charge of +3. So you can't just call it copper. You actually have to specify. So this compound is called copper 1 chloride. So the anion stays the same. We always append the INE to the IDE to get chloride. But this Roman numeral in parentheses here, this right now we can think of it as referring to the charge. If you've gotten farther in your study of chemistry, you can also refer to this as the oxidation state. As the oxidation state. So this is just the charge that copper atom, or now that copper ion, is taking. So let's take a look at iron. Iron can also take on a variety of charges or a variety of oxidation states. If you don't know what oxidation states are yet, don't worry. They're pretty much just the same thing as charge for our intents and purposes. And so again, let's use our strategy. Let's take a look at the charge on the anion. Oxygen has a charge generally of 2-, so times 3 is going to be -6. There are 2 irons here, so that means each iron must have a charge of +3. So this is equal to iron 3 oxide. Iron 3 oxide. Similarly here, mercury, even though it's not solid at room temperature, it's still a metal, it's still a transition metal. Oxygen, again, has a charge of 2 minus. 2 minus, that means this mercury must have a charge of 2 plus. And so this is mercury 2 oxide. Mercury 2 oxide. But, predictably, there are a few exceptions to this type 2 rule. Notably, exceptions with zinc and silver. So you might think here, okay, chlorine, our anion, charge of -1 times 2 is -2, so the zinc must have a charge of +2. Therefore, I'm going to write zinc 2 chloride. The problem with this is that zinc, as an ion, always loses 2 electrons. It always takes on a charge of +2, which means we actually don't have to specify that it's zinc 2. We can just call it zinc chloride. So this compound is just known as zinc chloride. Similarly, for this compound, fluorine halogen takes on a charge of -1. Whoops. Takes on a charge of -1. Therefore, silver must have a charge of +1. But silver always takes on a charge of +1. There's never a case where silver is going to have a charge of +2 or +3. So this is just called silver fluoride. We don't have to specify that it's silver 1 fluoride because silver only has one state in which it becomes ionized. It only has one oxidation state. It only loses 1 electron. Now we really hit the big leagues, and this, for a lot of students, for me especially, is extremely challenging, and these are called polyatomic ions, and I alluded to these earlier. These are just situations in which a group of atoms functions as one ion, and unfortunately, I know when I was in sophomore chemistry I had to memorize a bunch of these. I'm not sure what your teacher is going to inflict on you, but if you're planning on taking the AP or even the SAT 2 chemistry, you're probably going to have to memorize most of these that I listed here, and I've tried to list the most common ones for you. And we're just going to go through them and see if we can find any patterns that'll help us memorize these. And I will admit, I am looking at a sheet. I don't have all of them memorized all the time. I try to, but it's difficult, but I know you'll get there with me. So, let's go through them one by one. Nitrite, NO2 minus. Nitrate, NO3 minus. And here we see a little pattern. Nitrite and nitrate, they look pretty similar, they sound pretty similar, with the exception of these endings, ite and ate. And I can tell you that ite is always going to have fewer oxygens than ate. So if you see the same beginning to a polyatomic ion, but different endings, and if you see the endings ite and ate, you know that ate is going to have one more oxygen than ite. And we'll see that continue in our next example. Sulfite is SO3 2 minus, while sulfate, you can guess, SO4 2 minus. So if you can figure out one of these, then you can figure out the next one in this series. Acetate doesn't follow any rule, you just got to memorize it. It's C2H3O2 minus. And when in doubt, you can remember that almost all the polyatomic ions, with the exception of ammonia, which we'll see in a second, have negative charges. Hydroxide, this is an easy one. You'll become extremely familiar with this when we talk about acids and bases. That's OH minus. Cyanide is a cool one. You hear about it in the news sometimes. CN, the way I remember this, I think if there were a cyanide outbreak or a cyanide attack, it would be on CNN. We've got CN there. A little gimmicky, but it works for me. Phosphate, PO4 3 minus. And carbonate, CO3 2 minus. CO3 2 minus. And ammonia is an exception to the rule of the negative charge. Ammonia actually has a positive charge, and that's NH4+. And that also comes up a lot, so you probably won't have too much difficulty memorizing that one. But now let's return to our endings. I told you that ite indicates one fewer oxygen than 8. But what about these beginnings here? What about this hypo bit? And what about this per bit? Well, if I tell you that hypochlorite has one fewer oxygen than chlorite, well, then you should be able to figure out the rest. If I tell you that hypochlorite is ClO minus, chlorite has one more oxygen, so it's going to be ClO2 minus. Chlorate, remember 8 always has one more oxygen than ite, so it's ClO3 minus. And per, you can think of that as hyper. So hyperchlorate or perchlorate just has one more oxygen than chlorate, so it's going to be ClO4 minus. And again, there's really no other alternative just to memorize a bunch of those. And to help us remember, we're going to do a few quick examples. So what is this? We know the cation is cesium. So cesium, and then we'll take a look up here. ClO4 minus, oh, it's right there. So it's caesium perchlorate. Caesium perchlorate. And we don't have to worry about the ides or anything, we just worry about the polyatomic ion, its name. What about this one? So we know this is hydroxide. Hydroxide has a charge of -2. We know manganese is a transition metal, so we need to note its charge, which means manganese is going to have a charge of +2. So this is manganese 2 hydroxide. Manganese 2 hydroxide. And that's really all there is to it. So we have 3 different kinds of compounds, 3 different kinds of ionic compounds which you can name. Type 1, the easy kind, type 2 with transition metals, and type 3 with polyatomic ions. And to give you all a little practice, I wrote up a few questions for you. Why don't we do the first 3 first? So pause this video, answer these questions, rewind if you need to, and I'll be here when you're finished. Alrighty, welcome back. Here are the answers which you should have gotten. So here we go. This is a tricky one that has both a transition metal and a polyatomic ion. So what is this? NO3. Let's take a look back. This is nitrate, so it has a charge of -1. -1, which means this is going to have an overall charge of -3, which means the iron is going to have a charge of +3. So this is going to be iron 3 nitrate. Iron 3 nitrate. Easy one for you. This is just sodium iodide. Don't forget that ide in the end of the anion. And this is just to remind you that silver, even though it's a transition metal, always only takes a charge of +1. So this is just silver chloride. No Roman numerals involved. Next bit, I've given you the names for these chemical compounds, and I want you to write the elemental abbreviations for them. So hit pause, answer them on a piece of paper, preferably, or in your head if you're a hotshot, and then I'll be here with the answers. Alrighty, welcome back. So we can do the first bit of each question fairly easily. We know sodium, of course, is Na. But let's take a look. What is sulfite? Sulfite. SO3 2 minus. SO3 2 minus. So we know it has a charge of 2 minus, and sodium has a general charge of +1. We're going to have a 2 there, and then we're going to have SO3, and that's going to have a charge of -2, and that's going to have a charge of +2, so that balances. Next, calcium chloride. Well, again, this is an easy one. Calcium, we'll leave a little space for a subscript if we need it, and chlorine. Chlorine being our anion, calcium our cation. Well, we know that calcium takes on generally a charge of +2, chlorine -1, so we're going to need to have 2 chlorines to balance a charge of +2 for calcium. Here I'm telling you that iron is taking on a charge of +2, but what is nitride? Well, I don't expect you to have it memorized yet. I don't think I have that one memorized. So let's take a look. Oh, whoops. I even made a mistake. Nitride It's not even polyatomic. Nitride is just nitrogen. And nitrogen generally takes on a charge of -3. So we've got iron here and nitrogen here. Nitrogen generally takes on a charge of -3. I'm telling you this is +2. So this is a little tricky. All we're going to do is multiply these numbers by each other. So we're going to have 3 irons and 2 nitrogens. That's going to give this a charge of -6, this a charge of +6, so it all evens out. And that's actually, that little error there, that little mistake I made is useful because it's easy to confuse something like nitride with something like nitrate. Right? That could easily trick you up on a test or quiz. But always remember that if it's not ite or ate, it's going to be elemental, but if it is ite or ate, even with a hypo or per in front of it, it's going to be polyatomic. So I hope that was helpful, and I'll see you in the next video.